Okay. So, mali. Teka lang. Isa. Module 2. Okay. Okay. Okay, so last time we discussed about the principle of a transmission line, but we first categorized the so-called kinds of media. So the media is the one that interface the transmitter and the receiver, and we can classify it as a bounded and unbounded media. So air, water, and RF space are called unbounded media, while a transmission line is an example of a bounded media. Okay, so if we're going to ask which is better, so that is depending upon on the parameters we are like to pursue. So let's say in terms of interference, so it is better to use a bounded media such as transmission line. But in terms of costing, so it's very easy to deploy a wireless transmission media compare a transmission line. So it's up to you to decide what kind of parameters you wish to focus on. And also, we could categorize a transmission line as a balanced and unbalanced. So if it is a balanced line, both wires or both two conductor carries an energy like current, power, or voltage in opposite direction but equal in magnitude. While the unbalanced line is a kind of transmission media or line that has only one active wires, the other one is considered a ground. And the coaxial is one example of a unbalanced line. And also we discuss some of the properties of a both lines, a parallel wire line and coaxial line. And now we're going to discuss the characteristics and transmission parameter of transmission line. So any forms of transmission media has its own characteristics, both bounded and unbounded media, be it wired or wireless. Any form, the signal traveling, it will behave depending upon on its characteristics and parameters. In this module, the student will understand the behavior of the signal propagation in transmission line. They will understand transmission parameters, criteria, and some losses that affects the signals. Okay, so to start with the new topic under module 2. So, sabi nga, di ba kinakategorize natin yung ating transmission line as bounded and unbounded. At discuss na natin kanina and previously. The transmission line in the form of bounded media is subdivided into, again, balanced and unbalanced line. In order to connect a balanced line into an unbalanced line, it is better to use a balloon. So a special type of transformer that enable to match the balanced line impedance to an unbalanced line impedance. Because if there is no balloon, so the balanced line and unbalanced line can be connected, but don't expect to have a better performance. So it will result to a mismatch, causing some of the signal from the transmitter to be fed back again or return back to the transmitter, creating a pattern known as to be the standing wave ratio that will be discussed later on. Some types of balanced lines includes the twin lead parallel wire line, UTP and STP. So the difference between UTP and STP is that on the immunity to noise. So it's better to use a shielded twisted pair, but the cons is the cost. While coaxial line belongs to unbalanced line. So again, the balloon is a special type of transformer that is match the balance and unbalanced line. Now, sabi natin kanina, we're going to analyze a transmission line in terms of its characteristics. So ano-ano ba ang characteristics ng transmission line? So meron tayong tinatawag na electrical properties. So ano-ano yung mga electrical properties? Yung kanyang conductivity, okay? Conductivity of the conductor. So which is better for conductivity or better conductivity? So since we are after for the conductivity, better to use a better conductor, having a better conductivity. So ano-ano ba yung mga metals that has a better conductivity? Anyone? Ano-ano yung mga materials na have better conductivity? Gold, silver, but this is very impractical to use because of the cost and also the scarcity of the metals. So that's why usually ang transmission line are made up of copper and sometimes aluminum. So that is cost effective, and it is having a better conductivity to other metals. Okay. So also the electric constant of the insulator. So if we have a insulation between the conductor and let's say another conductor, that is called your dielectric. So what is the purpose of the dielectric? So if there is a dielectric constant, it tells the so-called velocity factor. So may kinalaman ang gagamitin mong insulation saan? Sa speed of propagation, because the speed of propagation is dictated by the velocity factor. So the velocity factor is usually 1 or less than 1. So the denser the materials or the denser the insulation than air means has a low velocity factor, and therefore the velocity of propagation is less compared to the speed of light. Okay? So kaya yung titingnan nyo yung ating dielectric constant. So usually in transmission media, the most common insulation na ginagamit is the PE or the polyethylene, sometimes a PVC, polyvinyl chloride, and some application can use the polyester. So that polyvinyl, polyester, and the polyethylene has a different dielectric constant that defines the velocity factor and the velocity of propagation of the signal within the transmission line. Okay, it's better to use an air as the electric. Mas maganda yon kasi the electric constant of air is roughly 1.0003, but to contain the air, it's very difficult. That's why you need a special tubular structure. So kaya sa coaxial cable, it is the solid, the plec, the air core is actually the strongest kasi meron kang special tubular structure. Okay, so we have also the properties or the physical properties. Pag pinag-usapan naman ng physical properties, dinidiktahan din yan ang parameters. Katulad ng wire diameter, so yung laki o taba ng wire na gagamitin mo ay may kinalaman sa tinatawag natin na characteristic impedance and attenuation of the transmission line na gagamitin. Also, the conductor separation that is dictated by the spacing of the insulation. Okay, so the separation between your conductors, be it a coaxial cable or a parallel wire line, have effect on the characteristic impedance that is based on the physical properties. Okay, so yan yung mga properties na kailangan nyo i-consider when dealing with transmission line. Conductivity, the electric constant, wire diameter, and conductor separation. Nagets? Susundan?
Yes po, sir.
Okay, thank you. So, major factor that affects the behavior of transmission line. So, ano-ano ba yung mga factors or parameters na makaka-apekto sa transmission line? Assuming na magkamukha siya ng diameter, magkamukha ng spacing, magkamukha ng conductivity, and etc. So, ano yung makaka-apekto sa kanya na change the behavior of the transmission line? Una, yung signal frequency. Okay. On our experiment, so again, the experiment will be sa school yon, no? Kaso, papaalam pa natin kay Dean, group. So, ibig sabihin, isang punta kayo sa eskwelahan, isang grupo to perform all the laboratory. So, i-video nyo yun. And then, the question will be answered by your reactions on the video. So, your data na iasagot nyo ay base sa i-video nyo sa actual laboratory nyo. So, kapag pinayagan, we could start group laboratory per batch yun, Monday, Tuesday, Wednesday. So basta sabihin nyo lang sa akin kung kailan kayo pupunta. Okay, so pag wala kayo, hindi kayo pumunta, meaning hindi nyo masasagot yung questions sa laboratory, and therefore, you will be having a grade of INC. Okay? So, kaya, kung gusto nyo, sabihin nyo ako, or i-schedule natin. Liwanag yun? And then,
Yes.
we have the transmission line length. Okay? So, signal frequency have something to do with the, in terms of the reactances. Kasi meron tayong mga reactances dyan. And as we all know, if we change the frequency, we could change the reactance and also change the impedance, because impedance is also a factor of reactance. And the reactance is a factor of frequency. So transmission line length is also a function of what? Attenuation. Sabi natin, sa attenuation, dalawa ang factor natin. Kung natatandaan nyo yung free space loss, ano lang yung free space loss? 92.4 plus 20 log of D in kilometer plus 20 log of F in gigahertz. So meron siyang factor ng free space loss na distance and frequency. Same with the transmission line. Because yung air or space as transmission media is the same as kung magbibehave din yung ating signal doon kapag pinopagate natin sa speed of, sa transmission line. So, may kinalaman din yung frequency and transmission line length. So, specifically, the transmission line length dictated the so-called attenuation. So, if the line is attenuated severely, meaning to say that the signal from the transmitter will not be reliably received from the receiver. Okay? So, that's why you need to consider also the length of the transmission line and the frequency. So, as the frequency and as the length increases, expected that the attenuation will be increased, and therefore the amount of losses incurred in the transmission line will be high compared to the other transmission line that has operating at a lower frequency and operating at a lesser length. Okay, so generally, if a conductor line's length exceeds 1/16 to lambda, this considered to be a transmission line. So, ibig sabihin, meron tayong transmission, yung conductor. Kapag ka daw nag-exceed na siya into lambda/6 of the wavelength, that conductor can be considered as transmission line. Okay? Yan yung general conclusion doon. Then, saan-saan natin pwedeng gamitin ang transmission line? Una, used to transfer the signal. Okay. Is it possible ba na makapag-transfer ka ng signal from the transmitter and receive with the receiver if there is no transmission medium? It is not possible. And therefore, transmission line can be used to transfer the signal because the transmission line is the one that will mediate or connect the transmission line, the transmitter, and to your receiver to be processed and received at the receiver. And also, the transmission line is used to generate pulses. Why? Paano nakakapag-generate ng pulses? As I've said, it can change the behavior of the signal parameter, which include the frequency. So, because of the parameters of the transmission line, mamaya pag-aaralan natin that inside the transmission line, there are so-called the primary line constant, which be composed of the different electrical properties like resistance, conductance, inductance, and capacitance. Meaning to say, if you change the frequency of a signal that is transmitted over a line, so the characteristic of your pulse will also change, and therefore you can generate a pulse from that transmission line. Okay, next is acts as a tune circuits or filter, because a transmission line will only allow a frequency that is suitable for its transmission. If it is not suitable for its transmission, and therefore that signal cannot be passed on the particular transmission line, and therefore it acts as a tune or a filter. So specifically a band pass filter. And also, since it is used to generate pulses, it can also generate phase shift and time delay. So how the transmission line will create a phase shift or time delay? If the lambda or the wavelength of the signal to be transmitted over a transmission line is short or um, exceeds the transmission line length, so it will cause a phase shift, maybe a time delay or a time advance, depending upon if it is exceeds or less than the transmission line length. Kasi yung sukat ng transmission line mo is different from the signal wavelength. If in case that the signal wavelength did not match to the transmission line length, therefore, you should expect a phase shift or a phase delay or phase shift or phase advance. Okay? So, anong maganda? So, depende sa transmission line. So, kakategorize natin ang transmission line as resonant and non-resonant. So, ano ibig sabihin ng resonant at non-resonant? I-discuss natin later on. Question? Naintindihan ba?
Naintindihan pa naman po, sir.
Okay. Next is, that is the very useful function of the transmission line is for the purpose of impedance matching. Ano ba yung impedance matching? So the impedance matching is very important parameter in transmission line, specifically when you want to connect a transmitter to your antenna or the antenna to the other load. So it is very important that matching of impedance is taken care of. Why? Because if the impedance of the line or the load will not match, there is so-called mismatch. And if there is a mismatch, you don't have to expect the maximum power transfer from the transmitter to your load. Ano ibig sabihin nun, sir? Ibig sabihin nun, yung energy mo from the transmitter will not be fully absorbed by your load. And again, some of the signal will be returned back to your source. So, ang ibig sabihin nun, there is a degree of reflection coefficient and standing wave ratio will occur. So, reflection coefficient and standing wave ratio will be discussed in the succeeding topic. Okay. So, ano-ano yung mga signal parameters na kailangan nating tandaan? Ito na din nakuha natin dati pa sa spectra. So, ano-ano ba yung mga parameters ng signal? Frequency. So, anong unit ng frequency? Hertz. How do we find frequency? That is the number of cycles per second. Meaning to say, if the frequency is something to do related yan sa ating period, so that is the reciprocal, okay, 1 over the period. Likewise, your period is the reciprocal of your frequency. So meaning to say, if the frequency increases, expected that the period of that signal will be decreased. Or if the period increases, expect muna that the frequency of the signal will decrease because they are inversely proportional to each other. Wavelength is defined as the length of the wave or the distance between two crests or two troughs. Meaning to say, for example, I have here a signal. Yan, kukunin ko yung wavelength. So this portion is known as to be the crest or the maximum excursion of your signal. So if you measure the distance between two crests, that is referring to your wavelength. Or pwede din natin kunin distance between two trough or the lowest portion. Okay? Trough is also your wavelength. Okay, so that is defined as your length of the wave. And the wavelength can be get using the ratio of the speed of light to your frequency. Also, the relationship of the frequency and wavelength are inversely proportional, meaning to say that if you increase the frequency, the wavelength decreases. If you increase the wavelength, the frequency decreases because they are inversely proportional. Okay, next, period. The period, that is the duration to complete the one cycle. So let's say mula doon hanggang dito. So that is one cycle. Okay. So measuring the distance, the time is known as to be the period because paano nasabing itong isa cycle? Positive cycle ito, then the negative cycle, then it will repeat into a positive, then to a negative. One complete cycle is one complete positive cycle and one complete negative cycle. Pag umulit, another period na yun. So ito lang yung tinatawag natin period. To complete one cycle of a wave. Then, the velocity of propagated. Ano velocity? The velocity of propagation. Ano ba yan? The velocity of propagation. Yan. Or the speed of propagation. So usually, dinidenote siya as the B propagated, BP, B sub P. So usually yan, ang velocity of propagation is equals to velocity factor multiplied by the speed of light. So yan yung ating velocity of propagation. Okay. Kung halimbawa gagamit tayo ng much denser insulation, we should expect that the velocity of propagation should be less than or equal to the speed of light. Pwede siyang maging equal sa speed of light if the electric is vacuum or air. Pero always mas mababa yan kung gumamit ka ng mga polyethylene, polyestyrene, or the polyvinyl chloride as insulation. Okay. Then, the velocity factor. So that will be your VF. So usually, the velocity factor is actually dictated by the square root of the electric constant. Yun tinatawag mo na relative permeability or permittivity. So ito ay unitless and the velocity factor is usually less than or equal to 1. If the velocity factor is equals to 1, meaning to say that velocity of propagation is equals to C. Kailan mangyayari yon? If your insulation is a vacuum, but paano ka magkakaroon ng insulation na vacuum? It is impossible. Pwede. Gamit ako ng air because the air is 1.0003. Gamit ka ng tubular structure but is less than that of 1. So ideally, pwede natin gamitin ng air but it is most costly to to construct rather than to have a flexible cable having the insulation of polyethylene or polyvinyl or polyestyrene. Okay? So ibig sabihin, the velocity factor is dictated by the electric constant. The electric constant is dictated by the density of the materials. Ibig sabihin, the denser the materials, the greater the electric constant. Also, the refractive index, kung natatandaan nyo. So, ang ibig lang sabihin nun, pala, the denser the materials, when I propagate the signal with that kind of materials, so the velocity of propagation is less compared to the speed of light. Agree? Agree ba kayo sa statement na yon? Ha? Again, that if the electric constant is denser, meaning when I propagate a signal with that, we should expect that the speed of propagation is less than the speed of light. Agree? Oo, agree na lang. Ay, di naintindihan. Oo, natural yon kasi mas mahirap makapass through ang isang signal, be it transmission line kung ang ginamit mong dielectric or insulation is denser than air. So, yung plastic ba denser than air? Yes. Magaan lang yung plastic sa tubig, pero ang usapan kasi natin ay air, hindi tubig. Again, if you're going to use water as the electric, pwede ba? Pwede din. Basta i-contain mo. Kaso, magkagamit ka ng water, alam mong water is denser than air, so you should expect that the signal will be less than the speed of light when you use that. And it is very impractical. How we're going to use water, the grounded na yung signal mo. Okay? So, because water is the conductor, your signal will be shorted with your insulation and conductor. Okay? Na susundan ba?
Yes po, yes po.
Yes po, sir.
Okay, next. Wave velocity. Ano ba yung wave velocity? Ito din yung velocity of the wave or velocity of propagation. The velocity of wave depends on types of wave and medium of propagation. Okay, remember, electrical power generates along the line in a form of TEM. Ano yung TEM? Transverse electromagnetic. Meaning to say, na kapag ka ipinropagate natin yung signal natin, which is transverse in nature, the electric field vector is perpendicular to the magnetic field vector, or the E fields is perpendicular to the H field. So the two E field and H field are also mutually perpendicular with the speed or direction of propagation. Okay? Naka 90 degrees sila lahat. Kasi nga, tinatawag siyang transverse. Kasi sabi natin, when we say transverse, it is automatically mean as perpendicular or 90 degrees to each other. Okay? In transmission line, electromagnetic waves travels at a speed less than the corresponding speed in a vacuum. Sinabi na natin dito kasi nga, in transmission line, ang gagamitin mong insulation ay polyethylene, polyvinyl, or polyestyrene that is denser compare sa vacuum or compare sa air. And sabi natin, only in the vacuum or in an air will have a velocity of propagation that is equal to the speed of light. Okay? So agree kayo that the velocity of propagation will be less than in a vacuum when it is propagated in transmission line. So that's all the principle behind that you should understand when you analyze the parameters of transmission line and also the parameters of the signals. Okay. So ngayon, kung halimbawa, na-considered mo na lahat yung parameters, okay? Check. Meron pa rin tayong tinatawag na transmission line losses. So bakit ba tayo nagkakaroon ng transmission line losses bago tayo i-discuss yun? Any idea from the group? Sa palagay nyo, bakit magkakaroon ng transmission line loss? Ano-ano kaya yung posibleng dahilan? Mr. De Luna? What do you think are the causes of transmission line loss given this principle na nalaman mo a while ago? Na.
Sir. Ayan po. Narinig po.
Sige.
Sir, yung IDO po, kaya po nagkakaroon ng ganun sa mga losses po, lang sa galing sa energy, sa mga losses sa conductors.
Okay. So meron tayong conductor loss. So, paano nagkakaroon ng conductor loss? Any idea? So, paano lagay mo? Bakit kaya magkakaroon ng conductor loss? Respond your answer, Mr. De Luna. That is correct. So, there is a conductor loss. Why?
Sir, sa ano po, dahil po sa flow of current.
Okay. So, di ba sabi natin before that a transmission line must be a metallic conductor. Hindi naman tayong pwedeng magkaroon ng transmission line that is not non-metallic. So, given I use a copper, which is a metal, so suitable for transmission. And a metal itself or a copper itself has the so-called resistivity. Natatandaan niyo pa ba yon? Resistivity is inherent properties of a materials that is dictated by rho L, Ayan, inherent property siya. Kaya nagko-constitute siya sa tinatawag natin na resistance. Okay, so kung kukunin natin halimbawa yung resistance natin, so that resistivity L over A, yan, di ba? So ito, yung resistivity na yun, present yan sa materials. So kung tayo gagamit ng conductor as a material, so technically, that conductor, which is copper, has a resistivity na that will constitute to a resistance. So this resistance is actually the one that caused the losses. Okay, and it is a function of the resistivity, the length over the area. Kaya nga 'di ba, sinasabi natin if you increase the length or if you decrease the area of your conductor, the tendency is to increase the resistance. And the resistance, as we all know, is the one that consumes the power with the so-called power loss. O kaya yung ating resistance, yung power loss, may formula tayo ng power, I squared R, no? That is the power loss. So unang cause yan, yung tinatawag natin na copper loss or the I squared loss because of the inherent properties of the copper or the material that has a resistivity that will soon generate the resistance that will oppose the flow of energy in that conductor or in that transmission line. Okay, whenever a current flows, one of these conductors or some energy will be dissipated in terms of heat. So, dumadaan yung ating mga charge carrier. So, magkakaroon ng tinatawag na vibrations or thermal agitations and it will be converted into a heat. Kasi yung movement of the electron inside the conductor will be converted into other forms of energy. So that kinetic energy will convert it to heat energy. Kaya umiinit. So the heat loss is a power loss. So kaya yung power loss is also the I squared loss. Yung formula nga natin ng I squared R. Another types of copper loss is due to skin effect. So ibig sabihin nun, kailan nagkakaroon ng skin effect? So for example, we have here a conductor. Okay, meron tayong conductor. Yan. Yan yung conductor natin. So supposedly, yung signal natin dito dapat dumaan sa gitna. Okay? Yan dapat yung ating signal, yung kuryente. For example, or other energy. It's because of the signal is hindi match yung kanyang frequency doon sa conductor na to. So that signal tends to flow at the outside of the conductor, dito sa balak niya pupunta. Doon siya dadaan yung kuryente natin or yung energy, causing heat. So that can be interpreted as the heat loss. Okay, so the current tends to flow near the surface of the conductor and it is mainly because that you are utilizing the transmission line at the wrong frequency. Ibig sabihin, kung halimbawa yung conductor mo ay 1 gigahertz, tapos yung frequency na ipinapasok mo doon ay 2 gigahertz, so there is a possibility that skin effect will happen because hindi kayang isupport ng 1 gigahertz line mo yung 2 gigahertz signal na ipinapasok mo sa kanya. Okay? And in order to minimize that skin effect, it is very important to use the special wire known as to be the Litzendrath wire or the Litz wire that is only to reduce the skin effect. Nagets? Good.
Yes po, sir.
Okay. Ano yung skin effect? Ayan, sinabi ng phenomenon yon that occurs at high frequency where the current flows on the surface of the conductor. Kaya, halimbawa, ganito. Nasa smart communication ka, tapos biglang bumaksak yung signal. Okay. Tingnan mo agad yung transmission line mo. Baka kasi hindi siya suited for that frequency na ginagamit mo. So, paano mo malalaman yung frequency? O, diba, meron tayong specification ulit. All of the equipment, all of the component of your system must have specification. Okay? So, or tinatawag natin na data sheets. The data sheets tells the performance and parameters of any parts of the system. Try to consult with that. At pag nakita mo, ay kaya pala mataas ang loss. Kaya pala bumagsak ang signal kasi nagkaroon ng severe copper loss due to skin effect. Why? because particularly this particular transmission line is basically used to operate at 2 gigahertz and yung nilalagay kong signal is 4 gigahertz. Something like that. Kaya tingnan nyo, mahalaga yun. Pag sinabing ng boss mo o supervisor mo, "Oy, Engineer Jasper Reyes, paki-imbestigahan mo bakit umano yung yung signal ng cell site natin doon sa Cabanatuan." Sabihin ni Jasper kasi hindi niya alam yung principle. Ay sir, nag-invento lang ng sagot si Jasper para makalusot lang. Sometimes you need to understand. So maybe it is kinetic or maybe mali yung conductor niya. Or maybe the connector. Ganyan. I have na-encounter ko na yung problem na yan. But hindi hindi sa transmission line, but rather in fiber. Okay? So meron kaming project before sa Saudi Arabia and then there is a severe loss in the link of the fiber that is 120 kilometers apart. Nag-test na kami ng fiber loss, okay naman. Tinest naman namin yung mga connectors and the patching, okay naman. So, hindi talaga maisip yung problema kung bakit gano'n. Still, the link of the fiber cause an excessive loss. And ang isang dahilan lang na nakita namin is mali yung connector type na ginamit. Ibig sabihin, yung ginamit na connector ay having a rule of APC, which is supposedly, merong rule na UPC, which is dapat APC siya, o yung angle physical contact. Maalaman nyo yun sa fiber optics later on. So, dahil sa isang lang na yun, no? So, kasi yung link ay single mode fiber, so supposedly, better to use an APC. Ang nilagay ng contractor ay UPC. It is, nag-ooperate lang siya sa multi-mode. So, nagkaroon ng parang mali. And dahil doon, nagkaroon ng loss. Okay. Ayun, ganun lang. Ibig sabihin, na-encounter niyo yun. And as an engineer, you should know it. Kasi magiging troubleshooter kayo. Ma-encounter yung mga problem kanyan. Okay? And it's very important to know that kind of concept, okay, that will solve your problem. Okay? Next, loss. So, tinatawag natin na dielectric losses. So, yung dielectric losses is very similar sa skin effect. Kaso, nag-cause yan ng dielectric natin. Diba, part ng ating transmission line is the conductor and the insulation or your dielectric or the separation between your conductor and other conductor. Losses that results from the heating effect of dielectric material. Yung mismong dielectric na ginamit mo ang iinit or the materials between the conductors. The loss is directly proportional to the potential difference of the two conductors. So, ibig sabihin yung potential difference ayan, that is your voltage. If the insulation breakdown voltage is less doon sa binilagay mong signal voltage, magkukos yan ng dielectric losses. So, ibig sabihin nun, hindi niya kakayanin yung potential difference between your conductor. And ibig sabihin nun, magkakaroon ng dielectric heating that soon leads to a dielectric losses. So, ang kaibahan nito sa skin effect is that ito ay kinokos ng voltahe or the potential difference doon sa iyong insulation or materials na separate. Next is the radiation and induction losses. Okay. Yung mga losses na to, magkakamukha lang siya. They are similar to both cause, but they similar siya sa skin effect, sa the electric, but it is caused by the fields surrounding the conductor. Ano ba yung fields? Di ba, meron niyang radiation o meron niyang electric field and magnetic field present. So once we study the waveguide, so there is the conditions there that the E field must be perpendicular to the H field para magkaroon ng conduction, etc. Ganon din ito sa conductor natin, sa transmission line. So, magkakaroon siya ng fields because of the fields that surrounds the conductor and the electromagnetic fields of the conductor that cuts through a metallic object. So, parang yung principle ng ano to eh, ng generator. So, di ba, once you expose the conductor to a magnetic field, the magnetic field is cut by the moving conductor. Parang ganun din ito. Almost similar to that. And magkukos siya ng induced voltage or induced current. As the result, the power is instead na makapag-travel siya throughout the line, so dahil nagkaroon siya ng radiation loss or induction loss, so hindi na siya, mababawasan na yung signal mo. So, loss na yon. Radiation loss is directly proportional to the frequency also. So, parang skin effect nga. And it can be minimized through cable shielding. Kanina, yung skin effect, mami-minimize mo using special kinds of wire na leads wire, but the radiation loss can be minimized through proper shielding. So, gagamit ka dito ng kable na merong shield or screen. But if not, what is the solution? As Ms. Madulid said before, you enclose your conductor or your transmission line inside a metallic tubing and properly banded it with the existing building ground, and that's enough. Okay? Next is the coupling loss. Yung coupling loss is yung pagdudugtong. Coupling loss occur whenever a correction is made to and from the transmission line. Example, meron tayong antena. Ang sukat na antena mo from your TV set is 30 meters. Eh dahil ang nabili mo lang ay 15, pinagdugtong mo. May epekto ba yon? 30 din naman yun eh. Yes, because there is a discontinuity on the line. Therefore, a coupling loss or misalignment loss will occur, and that discontinuity or that dugtong will tends to heat up, that will radiate and dissipate power. And sabi natin, pag nag-radiate and nag-dissipate ng power, ano mangyayari? May loss yun. Kaya hindi dapat pinagdudugtong ang transmission line. Kasi ang Pilipino, basta nakakita lang, minsan nga hindi pa nga transmission line ang nilalagay eh. Di ba? Conductor lang. Nagkatalo na. Tapos, ay, ba't ganito yung performance na ano? Ba't nagtanong ka pa? Hindi mo nga alam na kung ano yung kinabit mo eh. So the signal is suited to be propagated in transmission line, but you put it in a ordinary conductor. Okay? And pinagdugtong mo pa. Okay, kala mo sapat na 'yun. Okay? In a system, may kinalaman 'yon. So minsan baka yung pagdugtong mo na 'yon mag-cause ng enough loss to discontinue the signal that is transmitting from the transmitter towards to your antenna. And therefore, mababawasan yung tinatawag natin na effective radiated power. Hindi makakarating yung signal mo sa destination. Okay? Nasusundan ba?
Yes po, sir.
Naiintindihan?
Opo, sir.
Okay. Next. Tapos na yata eh. Teka lang, tilang ito, yan. Di ba sinabi ko kanina, yung transmission line ay may mga parameters. So, kasi ang transmission line is an special types of wire or conductor. Hindi siya basta-basta conductor lang. Meron siyang properties within. So, kaya yung transmission line are basically a well-constructed line or conductor that possess the different electrical properties. So, ano-ano yung mga different electrical properties natin? So, yung transmission line, pwede siyang sabihin na unbalance. Okay? Ito, unbalance ito. Okay? Bakit nasabi na unbalance yan? Okay? Unbalance line yan. Why? Because, mapapansin natin, the resistor, inductor, are present in series in parallel combination of conductor and capacitor, but take note of this, there is no RL at this particular portion. Meaning to say, this portion, dahil wala siyang component, ito ay mag-a-act as a ground. And sabi natin, if one conductor is ground and other has this signal, anong tawag mo doon? Kuya, ano nga? Di ba unbalance yun? Tama ba? Uy. Uy. Ano ko, ayawan na kayo sumagot. Bahala kayo. Kung sasagot dito, hindi ko mag-response.
Unbalance po, sir.
Ganun kasasabi pa lang, di ba? Pagka wala kasi dito, pansinin nyo, itong susunod, ano ba yung, ay wala pala doon. Okay, o sige. Yung example na to ay unbalance. Kasi, supposedly, pag sinabi nating balance, meron ditong RL, RL, RL pa rin. Kaya pag nakita nyo sa circuits, walang laman yung ilalim, ibig sabihin ground yon, unbalanced line. Pero kapag meron siyang RL, RL, RL dito sa ilalim, balanced line yon. Sir, palagi bang ganyan dapat ang arrangement ng transmission line? Yes. It should be series RL and parallel GC. So ang kapartner ni resistor ay si inductor, ang kapartner ni conductance ay capacitance. Palaging ganyan. In order to determine your characteristic impedance. Kasi ang maganda sa transmission line, if you do in this particular fashion, the characteristic impedance is constant throughout the line. Why? Because engineered yung materials. Ibig sabihin, special types yung materials, throughout the line, it is uniformly distributed yung parameters na yan. Infinitely long yan. Meron niyang RLGC, 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 etc. etc. And ibig sabihin nun, yung characteristic impedance ko is constant at every part of the line. Yung ibig sabihin nun, kung meron akong 75 ohms na 1 meter line, the same din yun na 75 sa 1 kilometer. Kasi nga, well-distributed yung mga RLGC na yan. Yun yung kagandahan sa transmission line. Hindi nababago ang impedance. Unlike sa isang ordinary line. Yung 1 meter mo, iba ang resistance nun sa 1 kilometer. Correct? Tama ba yun?
Yes po, sir.
Okay, iba. Pero sa transmission line, yung 1 meter ko, 75 ohms, kahit 1 kilometro, 75 ohms lang din. Yun yung kagandahan ng transmission line. Throughout the line, properly distributed yung tinatawag nating primary line constant na resistance, inductance, conductance, and capacitance. E ngayon, anong kinalaman ng length, sir? Attenuation. Okay? Mas mahabang line, mas attenuated yung signal mo kaysa sa mas ma-fixing line. Okay? Yun yun. Again, kapag meron ditong RL, RL, RL dyan, balance line yun. Since wala, unbalance siya. Okay? And that defines your characteristic impedance of that transmission line. Ngayon, ano-ano yung distributed parameters? Eh, yun na, sinabi natin. Resistance, inductance. Ano yung resistance? The transmission line parameter which is a function of length. This parameter distributed along the line and units is expressed as ohms per unit length. Ohms per meter, ohms per feet. Kaya tingnan nyo mabuti yung unit ha. Kailangan magkakamukha sila ng unit. Kung per feet siya, per feet din dapat yung inductance mo. Pag hindi, you need to convert that. And inductance distributed in series along. Again, in series siya ha. Resistance and inductance in series with the line and expressed as Henry per unit length. Kung resistance mo, ohms per meter, dapat ito naka-Henry per meter din. Okay? The presence of magnetic field caused by the current flowing along the line creates by this parameter. So, yung magka-partner ay resistor, inductor combination in series. Then, yung magka-partner naman na isa, conductance, G, that is the opposition to the resistance. And it's expressed as Siemens per unit length. Kung let's say, naka-meter ka kanina, Siemens per meter or mho per meter. And distributed parallel. Okay, naka-parallel siya. Capacitance parameter caused by two line charge carrier by the dielectric creating the capacitance. So since meron kang line, okay, isang conductor and another conductor that is separated, so there is so-called the capacitance na mabubuo dyan. Di ba? So, di ba sabi natin, the capacitance is equals to eta area over distance between the plate. Okay. Okay, yan yung formula ng capacitance natin. Yung ating electric materials, area of the plate and the distance between the plate. So if there is a distance, kunwari ito meron niyang charge and meron ka dito another line that is separated siya, yun yung distance na to, meron mabubuong capacitance and yun yung sinasabi na yan. Okay? That is the capacitance. The capacitance and the conductance are partnered and it is installed or constructed across or parallel with the line. And the unit is farad per unit length. Kung meter ang ginamit nyo kanina dito, it should be farad per meter. Basta kailangan magkakamukha sila ng unit. Pag hindi, you need to convert the unit length to other unit length. Naintindihan?
Yes po, yes po.
Okay. Now, tapos na. So, life's application and biblical implication. Transmission line is a special types of medium where the circuit parameters like resistance, inductance, conductance, and capacitance were uniformly distributed along the line. Because of these parameters, the signal transmission along the line will be affected and will incur some losses. Among of these signal losses that occurs in transmission line includes the conductor loss, radiation loss, the electric loss, and coupling loss. Signal loss in transmission line is a primary factor of distance and frequency or yung tinatawag nating attenuation yan. Okay. Okay, so life's application and thoughts to ponder. Transmission line or transmission is just like a life journey. Along the way, along the process, we experience life battles. We may feel losses like signals. We may encounter struggles and feel attenuated. No matter how hard life offers to us, to the extent that we are about to give up, remember that there is God who will amplify our signals, amplify our faith to face and continue the life journey. And that's all. And if you have any more questions, kindly raise it now. Question? Naintindihan ba? O nagsayang lang ako ng isang oras?
Ay, sir, tanong lang, sir. Ano
Sige.
po yung nasabi kanina na kailangan yung i-schedule nyo po yung ganun po?
Ayun.
Opo.
Di ba meron tayong laboratory? Ang laboratory kasi natin ay transmission line. Meron kayong 4 or 5 laboratory doon na ipe-perform. Ngayon, ang tanging option natin doon ay magkaroon tayo ng group scheduled laboratory. Papaalam natin kay Dean. Halimbawa, yung grupo mo, 5 kayo, pupunta sa school, ipe-perform nyo yung 4 na laboratory. So, isang puntahan lang kayo. So, siguro, it takes 3 hours para ma-perform yung laboratory na yon. I-video nyo na lahat para i-refer nyo yung sagot nyo doon sa video nyo na ginawa. Okay? So, i-upload yon sa Canvas. Kasi, ilalagay ko yung mga questions sa Canvas at sasagutan nyo lang kapag nagawa nyo na yung laboratory. So, mag-group kayo. Kung kayo ay 20, 30, so 6 group. So, 6. Mayroong 6 group na pupunta sa school. Another question, sir, paano kung kagrupo ko? Hindi pwede. Ako lang ang pwede. Sige, ikaw lang yung mag-perform ng laboratory. I-relay mo na lang sa kanila yung data na makukuha mo. Pwede din naman yun. Hindi talaga pwede eh. Ba't ako mamimilit? Baka makasompa tayo sa chat. Okay? So, pwedeng kahit isang representative or 2 representative sa isang group, yun yung magpe-perform ng laboratory sa school. Okay? pero masaya yung mga absent. Meron silang data, tapos hindi sila nag-perform, di ba? So, advantage yun mga nag-perform. At least, the data that you have is a first-hand experience and you know it kung bakit naging gano'n. Kasi sila, dahil hindi sila present, maybe they have the answer but they don't have the experience nung pinperform yan. Okay? Ms. Champuan?
Okay po, thank you po.
Okay, another question? Question? Na, with regards sa topic.
Nagigets pa naman po, sir.
Okay, how about you, Ms. Madulit?
Nagigets din naman po.
Okay, so sa
Malinaw
mga
naman.
susunod, we will be having a calculations na. Ngayon kasi puro mga objective type pa yan, mga principles, before we proceed sa calculation. Kasi we cannot interpret the calculations if we don't know the principles behind it. So, kailangan talaga nating maintindihan ito. And once you na-gets yun na yan, so kaya pala ganito yung calculation. Mga ganun. So, ano nyo na, mabivisualize nyo na kung bakit hindi nakukuha ang data. And then, ano pa ba? Ayun, basta magkakaroon tayo ng mga calculations. Actually, puro calculations na to pagka sa mga susunod. Okay, so ng tanong? Pag walang tanong, ako magtatanong. Last na tanong.
Sir,
Yeah.
kasi po, di ba, dapat this week or next week po yung schedule ng prelim exam ng sa calendar, po. Natutuloy po ba yun or kailan po namin pwedeng i-expect na magkakaroon ng exam?
So, since nagkaroon ng movement ng start ng class, so I think magkakaroon ng movement din ng schedule ng prelim. So, kung na-move siya ng 2 linggo, mamumove ng 2 linggo yun. Ibig sabihin, mamumove din yung bakasyon nyo up to May siguro. Ganon. Okay?
Okay po, thank you po.
Okay, another concern?
Wala naman po atang bakasyon, sir. O JT.
Gusto
Ako
nyo
ba?
makatapos Ano ba gusto nyo? May bakasyon pero hindi tapos o what? Tapos OJT nyo pa. I don't know kung paano OJT nyo, kung papayagan na kayo. So, mas maganda sana payagan ako para hindi ako mahirapan. Kasi yung nakaraan, nahirapan ako doon sa OJT. Ako naging supervisor ng OJT. Wala namang nangyari. Napagod lang ako. Okay? Pero sige, okay lang. Kesa naman natapos ang OJT nang wala. So actually, nag-design sila ng actual sa Wisleyan. And then, okay, so ano yung tinatawag natin na corona loss? Nakalimutan ko pala. Corona loss. Kasi part yun ng transmission line loss. So yung corona loss is just like a radiation loss kung saan nagkakaroon ng parang glow doon sa outer part ng conductor mo. So, parang corona ng sun, gano'n. So, may kakaroon ng glow. So, dahil na din sa skin effect. So, yung signal mo, nagpapass through sa surface ng conductor. And makikita nyo yan, usually, kung kayo ay nasa bukid, na meron, di ba meron doon yung mga high tension wire? Pagka masyadong mataas yung corona, makikita nyo that transmission line or power line will glow or emit some kind of light. Parang ganon. So, parang magkakaroon ng aura yung line. So, that indicates that line possess the corona loss. Okay, or the glowing of the outer part of your conductor. Okay, so kung wala nang tanong, Miss Aliana, take the photo.